At first, it didn't feel important. Just another faint point of light drifting across a black screen. Cold, silent, easy to ignore. Out there, beyond Mars, beyond the comfort of familiar orbits, something was moving. They named it 3I/Atlas. A label, a number, a routine discovery in a sky full of routine discoveries. Astronomers have seen this story thousands of times before. A distant object appears. Software flags it. Coordinates are logged. A new dot is added to a growing map of space. No headlines, no urgency. Just another visitor passing through the ecliptic like dust on a cosmic road. But sometimes, the quiet ones are the ones that matter most. Because from the very first night it was observed, something felt off. Not wrong enough to stop the process. Not strange enough to raise alarms. Just enough to make a few scientists pause a second longer than usual. They stared at the numbers, then stared again. The object's reflectivity didn't match expectations. Not by much, just a small bend in the curve. The kind of thing you usually blame on bad angles, or weak signals, or tired eyes at 2 a.m. So they logged it, adjusted the model, moved on. That's how science works. You don't jump to conclusions. You don't chase ghosts. You trust the data until the data gives you a reason not to. And at first, 3I/Atlas gave no reason at all. It moved calmly along its path, sliding across the starfield like it had done this before. Its trajectory looked clean, predictable, almost polite. No dramatic tail, no violent outgassing. Just a steady traveler approaching the inner system, slowly drifting closer to the sun. Days passed, then weeks. And with each new observation, the light coming off 3I/Atlas did something subtle. It hesitated. The light curve, that smooth rise and fall scientists expect, didn't flow naturally. It lagged, just slightly, as if the brightness was reacting late, as if something was deciding, then responding. That shouldn't happen. Rocks don't hesitate. Ice doesn't pause to think. Light reflects instantly. Always. Yet here it was, delayed by fractions of a second. Too small for headlines, too quiet for panic, but enough to make one astronomer write a note in the margin. Check again. When they did, the delay was still there. Not growing, not shrinking, consistent. Like a heartbeat you only notice once the room goes silent. Still, nobody said the word anomaly out loud. Because the universe is messy. Dust clouds scatter light. Rotation can play tricks. Distance can lie. There are 100 boring reasons before one impossible one. So they widened the observation window, pulled data from different telescopes, different countries, different skies. Chile, Hawaii, Spain. The delay followed it everywhere. Same pattern, same pause, as if 3I/Atlas was answering, not shining. That's when the feeling changed. Not fear, not excitement, something quieter. Discomfort, because the numbers didn't feel broken. They felt deliberate. And that's the most unsettling kind of data. The object's surface didn't behave like rough ice or spinning stone. Reflectivity shifted in smooth steps, not random flickers, as if parts of it were turning, then stopping, then turning again. Not tumbling, choosing. No one wrote that down. Not yet. Instead, the report stayed clean, Calm language, safe words. Unusual, but within margin. Likely rotational effects. Further observation required. NASA had seen strange things before. Interstellar objects. Fast movers. Odd shapes. This wasn't the first visitor from outside our solar system. But something about this one felt aware of the sun. As 3I/Atlas moved closer, its brightness didn't simply increase, it adjusted. Almost like squinting, almost like shielding itself. That's not how dead matter behaves. Still, no alarms. Because science moves slowly on purpose, and because saying the wrong thing too early can destroy careers. So the discovery stayed quiet, buried in data logs, hidden in late-night recalculations, whispered in private emails that ended with one line, probably nothing. But deep down, a question had already formed, a dangerous question. Why does this object feel like it's late on purpose? Why does the light respond instead of reflect? Why does every model work better when you add a delay that shouldn't exist? It wasn't watching us. No one believed that. Not yet. But it felt like it was doing something while we were watching it. And that feeling is hard to shake once it settles in. Because the universe doesn't care if we look at it or not. Stars explode whether we notice or not. Comets burn whether we measure them or not. They don't wait. But 3I/Atlas seemed to. Just a little, just enough. As it slipped along the ecliptic, drawing closer to perihelion, the sun's pull grew stronger. Radiation increased. Pressure rose. This was the moment when secrets usually reveal themselves. Tails flare. Surfaces crack. Hidden ice screams into space. Everyone expected something dramatic. Instead, the data stayed calm. Too calm. The reflectivity didn't spike, didn't collapse. It adjusted, again, like a dimmer switch. Not a burst, not a failure, a response. And somewhere between those charts and that quiet sky, someone realized something unsettling. This wasn't just a discovery. It was a beginning, a soft opening note to a story no one was ready to tell. Because if the data was right, if the delay was real, then the most dangerous possibility wasn't that 3I/Atlas was strange. It was that it was designed to look normal. And that realization brings a new kind of silence. The kind where you don't rush to tell the world. The kind where you watch and wait and double-check everything. Because once you cross that line, there's no going back. And 3I/Atlas kept moving, quiet, unannounced, unbothered, as if it had all the time in the universe. And as the sun grew larger in its path, the question grew larger in ours. Was this just another rock drifting through space? Or was this the moment when observation stopped being one-sided? The sky stayed silent, but the data had already begun to speak. The closer it moved to the sun, the more it should have made sense. That's how this usually goes. As an object approaches perihelion, the rules are clear. Ice heats up, gas escapes, dust blooms outward. The light curve smooths, it always smooths. Every comet ever studied tells the same story. Messy at first, then predictable. Chaotic, then calm. That curve is like a fingerprint. You can recognize it without even looking at the name. But 3I/Atlas didn't follow the script. As the sun grew brighter in its path, scientists waited for the familiar rise. They expected a clean arc of light. a steady climb as radiation woke the surface. Instead, the curve stuttered, not violently, not obviously, just enough to feel wrong. It rose, then flattened, then rose again, then paused, like someone tapping the brakes in empty space. At first, they blamed dust. Comets are dirty things. Their surfaces crack, jets burst unevenly. Dust can block light. Gas can scatter it. So they adjusted the models. They added noise. They added spin. They added irregular shapes. But no matter how they tweaked the equations, the curve refused to behave. It wouldn't smooth out. Not as the sun got closer. Not as pressure increased. Not even as surface temperatures crossed thresholds that should have forced activity. The light curve stayed jagged, but controlled, and that's the detail that made people uneasy. Natural chaos doesn't repeat itself cleanly, but this did. Every dip came back, every rise returned at nearly the same interval. Not perfectly, but close enough to notice. It was like listening to wind and slowly realizing it had a rhythm. Somewhere in a quiet office, a researcher overlaid the new data with older frames, then leaned back. Because the pattern didn't just repeat once, it repeated across days, across angles, across different telescopes, different instruments, same behavior. That shouldn't happen. Different sensors make different mistakes. Atmosphere interferes. Calibration drifts. Angles lie. Yet the curve stayed consistent, almost stubborn, as if the object itself was maintaining it. The word anomaly finally appeared. Not in a press release. Not in public logs, just in private notes. Because anomalies are dangerous. They invite attention. They invite questions that don't have safe answers. So scientists did what they always do when something feels uncomfortable. They tried to break it. They assumed the light was lying. Maybe the surface was unusually dark. Maybe metallic grains were absorbing radiation. Maybe the object was hollow. Each idea worked for a moment, then collapsed. Because none of them explained the timing. The pauses were too clean, too intentional. The light curve didn't just misbehave, it behaved differently on purpose. As perihelion drew closer, the sun's influence intensified. Solar wind pushed harder, radiation pressure increased. This is the point where comets usually lose control. They flare, they fracture, they scream into space. 3IATLAS did none of that. It adapted. When brightness should have spiked, it leveled off. When activity should have surged, it held back, almost like regulation. That's when the whisper changed tone. Not, "This is strange," but, "This is responding." No one wanted to say it out loud, because response implies awareness. And awareness implies intent. And intent implies something no one was prepared to face. Still, the data didn't care about comfort. The light curve began to show phase shifts. Tiny changes in timing, like the object was turning surfaces toward the sun, then away, not tumbling randomly, choosing angles, choosing exposure. And with every adjustment, the curve stayed just within the edge of believability. Never dramatic enough to scream artificial. Never normal enough to relax the mind. Balanced, precise, controlled. It was the worst possible place for doubt to live. Because you can't dismiss it, and you can't prove it. NASA's internal discussions grew quieter, not louder. The louder something is, the easier it is to contain. Silence is harder. Silence spreads. Emails shortened. Language softened. Instead of wrong, they said unexpected. Instead of impossible, they said unlikely. But the meaning stayed the same. This object was not behaving like dust and ice. And if it wasn't dust and ice, then what was shaping the curve? Some suggested geometry, a flat surface, a strange rotation. But geometry still follows physics. It doesn't hesitate. It doesn't pause when conditions demand reaction. It doesn't smooth itself out to avoid extremes. Unless it's designed to. That thought stayed unspoken. But it hung in the room because everyone knew the history. Oumuamua had already cracked the door open years earlier, an object that didn't outgas. That accelerated without explanation. This felt different. More subtle, more careful. Almost like a lesson learned, as if whatever passed through before had been noticed. And this time, it didn't want to be obvious. As perihelion neared, public-facing reports stayed boring. Charts, tables, footnotes, nothing alarming, nothing clickable, just numbers doing their job. But behind closed doors, something had shifted. Not belief, suspicion, the most dangerous stage of curiosity, because suspicion doesn't need proof. It only needs patterns, and the light curve was full of them. Patterns that didn't scream, patterns that whispered. The object reached its closest approach. The sun blazed. This was the moment everyone expected the curve to finally break, to spike, to flare, to give up the act. It didn't. Instead, it normalized, not into a natural curve, but into a stable one, flat where it should peak, smooth where it should roar. Like a machine idling, like something that had finished adjusting. And then it held. That was the moment a few scientists stopped asking what it was and started asking why. Why approach the sun at all? Why regulate brightness? Why stay just quiet enough to avoid attention? Why behave in a way that mimics nature but never fully commits to it? Those questions had no safe answers, so they stayed buried. Because once you suggest intent, you have to ask intent's shadow, purpose. And that's not a question science likes to answer in public. The light curve stayed wrong, not broken, not chaotic, wrong in a way that felt designed. And as 3I/Atlas passed perihelion and began its slow retreat, the curve didn't relax. It remained controlled, as if the object had learned exactly how bright to be, exactly how visible, exactly how much to reveal. And that realization carried a chilling thought. What if the light curve wasn't failing to smooth out? What if it was smoothing itself for us? The sun began to shrink behind it. The danger window closed. But the unease remained, because anomalies fade, patterns don't. And in the next chapter, those patterns would stop hiding in brightness and begin speaking in heat. At first, nobody noticed it, because space is loud, not in sound, but in data. Cosmic rays spike sensors, stars flicker, electronics drift. Noise lives everywhere. Every astronomer learns this early. Most strange signals are lies. So when the first tiny spike appeared in the brightness logs of 3I/Atlas, it was ignored. Just a blip, a hiccup. The kind of thing you delete without thinking. But then it happened again. Same size, same shape, same timing. Still nothing alarming, until a second observatory saw it too. Different continent, different telescope, different night sky, same pulse. That's when the silence in the room changed, because coincidence has limits, and this was brushing right up against them. The pulse wasn't bright, it wasn't dramatic. It hid inside the noise, like it didn't want to be found. A soft rise, a gentle fall, then nothing, and then again. At first, they thought it was rotation. Objects spin, surfaces catch light. But rotation creates smooth waves, not sharp beats. This wasn't a wave, it was a tick, barely visible, but precise. Someone plotted the timing, then plotted it again. The intervals matched, not exactly, but close enough to make the hair on your arms stand up. Because natural systems drift, they wobble, they decay. They don't keep time. This pulse did. Every few hours, there it was. Not drifting, not fading, like a metronome buried under static. As more data came in, the pattern sharpened. The pulse wasn't random across the surface. It came from the same region every time. Like a lighthouse beam, but aimed inward. And then came the moment nobody wanted. Another observatory confirmed it. Then another. Chile, Arizona, Australia. Different instruments, same pulse, same rhythm, same delay. That's when the word signal appeared, quietly, carefully. Not in reports, not in emails that could leak, just in whispered conversations. Because a signal means intent, and intent changes everything. At first, they tried to explain it away. Thermal stress, microfractures, surface shedding. But fractures don't repeat cleanly. Stress doesn't keep perfect time. And shedding doesn't wait patiently between events. The pulse didn't care about solar wind. It didn't care about distance. It didn't care about angle. It just happened. Over and over. The scariest part wasn't the pulse itself. It was how small it was. Just strong enough to be detected. Just weak enough to be ignored. Like it wasn't meant to announce itself. Like it was meant to be found only by those who look too closely. Someone asked the question everyone was avoiding. What if this isn't for us? Because not every signal is a message. Sometimes it's a function, a process, a system doing what it was built to do. The pulse lined up with the light curve shifts. Every time brightness adjusted, the pulse followed, as if it was measuring something, or synchronizing, or checking its own state. The data suggested the pulse wasn't reacting to the sun. It was reacting to itself. That idea scared people more than aliens ever could, because self-referencing systems don't belong to rocks. They belong to machines. Still, nobody said that word. Instead, they did what scientists always do. They listened longer. They widened the timeline. They went back to the earliest detections. And there it was, faint, buried, but present. The pulse hadn't started near perihelion. It had been there from the beginning. We just weren't listening yet. And when they measured the spacing between pulses more carefully, something impossible appeared. The interval wasn't random. It wasn't tied to rotation. It wasn't tied to orbit. It was tied to time. Consistent time, as measured here, on Earth. Seconds matched. Minutes aligned. Even accounting for distance, the math held. That shouldn't be possible. Signals from deep space stretch. They smear. They drift as space expands. But this pulse corrected itself, like it knew where it was being observed from, like it accounted for delay. That realization stopped conversations mid-sentence, because now the question wasn't, what is it doing? It was, who is this for? Some argued it was coincidence. They always do. Coincidence is comforting. Coincidence doesn't ask you to rewrite your understanding of reality. But coincidences don't survive scrutiny. And this one had survived everything thrown at it. The pulse stayed steady, unbothered by doubt, unmoved by denial, almost patient, as if it knew time was on its side. NASA didn't announce it. They didn't confirm it. They didn't deny it. They simply stopped talking about brightness altogether. Reports shifted focus. Orbital mechanics, mass estimates, surface composition guesses, anything but the pulse. Because once the public hears repeating signal, the story escapes. And nobody wanted that, not yet. But among those watching closely, the mood had changed. This wasn't passive observation anymore. It felt like eavesdropping, and with that came an uncomfortable question. If this pulse is real, if it's deliberate, then what is it measuring? Distance? Energy? Time remaining? Or something else entirely? One researcher noticed something chilling. The pulse rate shifted, slightly, after major observation campaigns. When we looked harder, it adjusted. Not immediately, but soon enough to notice, as if increased attention altered its behavior. That idea was never written down. It lived only in thought, because writing it would mean admitting the worst possibility. That observation itself was being observed. The pulse didn't speed up. It didn't slow down. It fine-tuned. Like a clock adjusting to a new reference. Like a system syncing to an external standard. Us. And that raises a terrifying implication. What if this pulse isn't a message? What if it's a countdown? Not dramatic, not urgent, just steady. Unemotional. Counting toward something already decided. The universe has no obligation to explain itself. But patterns demand interpretation, and this pattern felt ancient. Patient. Not rushed, like something that had crossed interstellar space with one goal, and plenty of time to reach it. As days passed, the pulse continued. No change, no response to questions. Just repetition, like breathing, like waiting. And in that quiet repetition, another truth settled in. We didn't discover the pulse. We caught up to it. It had been there, all along, doing what it was built to do. And the real question wasn't whether it was a signal. The real question was far more unsettling. If this pulse is counting time, what happens when it stops? The answer didn't come. The pulse continued, and somewhere between those beats, human certainty began to fade. Because noise becomes signal the moment you realize it was never noise at all. And in the next chapter, that signal would begin to change something even harder to ignore. Heat, something that should never lie. Heat never lies. That's what scientists believe. Light can scatter, signals can distort, noise can fake meaning. But heat is honest. It follows rules older than language. Closer to the sun means warmer. Farther away means cold. No opinions, no exceptions. That's why what happened next felt impossible. As 3IATLAS moved through its closest approach, researchers turned their attention to temperature. Not curiosity, routine. Thermal data is boring most of the time. Predictable. Clean. You point the instruments. You watch the numbers rise. You nod and move on. But this time, no one nodded. Because the heat curve didn't climb. It dipped, right when it should have surged. As solar radiation peaked, the surface temperature of 3I/Atlas fell. Not by much. Just enough to notice. Just enough to make someone check the calibration twice. Then 3 times. They assumed sensor error. They always do. Space is harsh. Instruments degrade. Readings drift. So they cross-checked with infrared arrays. Then with independent thermal telescopes. Different tech. Same result. The object was cooling while being roasted by the sun. That shouldn't happen. Ice sublimates. Rock heats. Everything absorbs energy. Nothing sheds it without a process. And yet, the numbers kept falling. Then, slowly, rising again. Not randomly. In steps, like breath, cooling, holding, warming, cooling, holding, warming. The pattern matched the pulse. That's when the room went quiet. Because now 2 independent systems, light and heat, were moving together, synchronized. That's not physics, that's control. They searched for explanations. Maybe reflective dust was venting heat. Maybe microjets were releasing cold gas. But outgassing leaves scars. Jets leave signatures. Plumes show up in spectra. There were none. The surface looked intact. No eruptions, no fractures, no violent release of energy. Just smooth thermal transitions. As if the object was redistributing heat internally. That idea caused discomfort. Because redistribution requires structure. Channels, layers, insulation, design. As 3I/Atlas began to move away from perihelion. Logic said the temperature should drop fast. The sun's grip weakened. Radiation faded. But the object did the opposite. It warmed. Slowly, carefully. Like a furnace turning itself back on after stress. Holding a stable range. Never too hot. Never too cold. Balanced. Someone plotted the thermal data against orbital distance. The curve should slope downward. Instead, it flattened, then stabilized, like a thermostat finding its set point. No natural object does that. Even planets struggle. Yet here was something no larger than a city, managing heat better than Earth's satellites. The phrase, active thermal regulation appeared, then disappeared, replaced by safer language, unusual thermal inertia, unexpected heat retention, words that soften the truth, because saying regulation means intent. And intent leads to engines, or systems, or something far worse. Someone asked the quiet question, what's powering it? Because you can't move heat around for free, energy must come from somewhere. Chemical reactions? None detected. Radioactive decay? Too weak. Solar absorption? That explains heating, not cooling. The math didn't close. No engine signature appeared. No exhaust, no waste heat. It was efficient. Too efficient. That's when another detail emerged. The temperature shifts followed the same timing as the pulse. Not exactly, but close enough to align. Like a system checking itself. Then adjusting, checking, adjusting. The pulse wasn't just counting. It was coordinating. That idea didn't sit well with anyone, because coordination implies purpose. And purpose raises the most uncomfortable question of all. Why regulate temperature at all? Comets don't care if they burn. Asteroids don't mind cracking. Only things that need to function care about staying within limits. Machines care. Life cares. 3I/Atlas showed no signs of biology, no organic signatures, no water vapor clouds. Whatever this was, it wasn't alive. But it behaved like something that wanted to keep working. And that's worse. As the object drifted farther from the sun, the thermal pattern changed again. Instead of dropping quickly, it tapered. Like it was releasing stored heat slowly, deliberately. Nothing leaked, nothing wasted, just careful management. That's when someone made a comparison that never left the room. It's acting like a spacecraft, without thrusters. No one responded, because everyone understood what that meant. Spacecraft regulate heat because they have to. Electronics fail if they overheat. Structures warp. Systems collapse. Thermal control is survival. So why would a random interstellar object behave like it has systems to protect? The reports grew shorter. Graphs replaced explanations. Charts spoke louder than words, and every chart told the same quiet story. This object was not passive. It was not reacting. It was maintaining. NASA didn't deny the data. They just stopped highlighting it. Thermal analysis was quietly downgraded in importance. Focus shifted again. Anything to avoid the question forming in everyone's mind, because once you ask how, you're one step away from asking why. And why has no comfortable answer here. One scientist noticed something chilling. The thermal stabilization range matched known tolerances for electronics. Not exactly, but close enough to feel intentional. Another noticed the cooling phases lined up with solar exposure peaks, as if the object shielded itself, then recovered. Shielding doesn't happen without layers, without design, without foresight. The object wasn't just surviving the sun, it was managing the encounter. Like it had done this before. Like perihelion wasn't a threat, just a phase. That thought lingered. Because interstellar space is cold, brutally cold. Anything crossing it for millions of years needs protection. Heat management isn't optional, it's essential. And suddenly, the idea of accident felt small. This wasn't a rock kicked loose by chance. This wasn't debris wandering aimlessly. This was something built to endure, built to pass through stars, built to wait. And that raises a haunting question. If this object regulates heat so carefully, what happens when it stops caring? Because machines shut down when their task is complete. They don't fail dramatically. They simply go quiet. As 3I/Atlas continued outward, the thermal curve began to relax. Not collapse, relax. Like a system winding down. No panic, no breakdown. Just stability giving way to silence. And in that silence, the fear grew. Because heat never lies. And the heat was telling us something simple and terrifying. Whatever this is, it's not just drifting through our solar system, it's passing through on purpose. And in the next chapter, we would begin to realize something even harder to accept. This object wasn't just managing itself, it was learning where to look. At first, the surface looked simple, dark, uneven, unremarkable, just another object carved by time, scarred by radiation, worn down by the long cold of interstellar space. That's what everyone expected to see, because most things that drift between stars look the same in the end: burned, pitted, dead. But when scientists began mapping the surface reflectivity of 3I/Atlas in detail, that expectation fell apart. The numbers didn't stay still. One region would brighten, then fade. Another would darken, then suddenly sharpen. Not gradually. Suddenly, like a switch being flipped. At first, they blamed rotation. Everything rotates. Objects spin. Surfaces turn. Light shifts. That explanation is comfortable. Rotation explains almost everything, until it doesn't. Because rotation is smooth, predictable. It follows momentum. But what they were seeing wasn't smooth. It was selective. Sections of the surface seemed to change reflectivity independently of the rest, as if parts of the object were turning toward the sun, while other parts stayed still. That shouldn't happen. A solid rock rotates as one piece. It doesn't choose which face shines. Yet the data showed something else. Bright patches appeared, held their angle, then disappeared. Not sliding, not drifting, stopping, holding, then moving again. The timing lined up with everything else: the pulse, the thermal shifts, the light curve adjustments. It was all happening together now, no longer isolated oddities. A system. Someone zoomed in on the reflectivity graphs and whispered something that changed the mood instantly. They look like panels. Not literal panels, no clean edges, no sharp corners. But behaviorally, that's what they were. Flat responses, controlled angles, purposeful exposure. Like solar arrays adjusting themselves, like mirrors turning to catch or reject light. The idea felt absurd, so they pushed back. Maybe it was a strange shape. Maybe the object was elongated. Maybe it was tumbling in a complex way. They ran simulations, thousands of them. Random shapes, chaotic spins, extreme geometries. None of them matched the data cleanly. The changes were too fast for tumbling, too localized for rotation, too coordinated for chance. That's when a new possibility entered the room. What if it's not spinning? What if it's orienting? That single word made everything heavier, because orientation implies choice. It implies feedback. You don't orient without knowing where you are. And knowing where you are means sensing. The reflectivity changes weren't constant. They happened when solar intensity crossed certain thresholds. Too bright, the surface darkened. Too dim, it brightened, like it was maintaining balance, protecting itself, optimizing. That's when someone noticed something subtle and deeply unsettling. After major observation campaigns, after radar sweeps, after focused imaging, the reflectivity behavior shifted, not dramatically, just slightly. Like the object had learned which angles mattered, like it was responding to being watched. No one wanted to believe that, because belief isn't required for fear. Evidence is. And this wasn't evidence yet, just an accumulation of discomfort. Still, the phrase adaptive surface appeared in private notes, then vanished. Replaced by safer language, dynamic albedo variation, unexpected surface response. words designed to calm the mind. But the behavior didn't calm anyone. Because the surface wasn't just reacting to the sun, it was reacting to conditions. And conditions change, which means this object wasn't following a script. It was updating it. That's when the machine analogy stopped feeling theoretical. Machines adjust, they optimize, they learn where to look, and the reflectivity shifts began to show preference. Certain angles repeated, certain orientations returned again and again. Not random. Chosen, almost like the object had discovered the most efficient way to manage exposure and stuck with it. That's learning, not intelligence, not consciousness, but adaptation, the simplest and most dangerous trait of machines. No one suggested aliens, not directly. This wasn't about who built it. It was about what it was doing now. And right now, it was behaving like something with a goal. As perihelion passed and the sun's influence weakened, the surface behavior didn't stop. It refined, less dramatic shifts, smaller adjustments, like fine-tuning after a test run. The object had passed through the most intense part of the system and come out stable. Better than before. That thought lingered, because learning implies memory, and memory implies experience, which leads to an unsettling idea. What if this wasn't its first star? What if this object had done this many times before, passing through systems, adjusting, optimizing, leaving nothing behind but questions? The reflectivity shifts grew less frequent as 3IATLAS moved outward. Not because the system failed, because it no longer needed to adjust. Like a machine that had completed calibration. That's when something else became clear. The surface wasn't designed to communicate. It wasn't signaling. It wasn't waving. It was protecting function, which suggests the object had something to preserve. Something inside. And that idea, that there might be an interior worth shielding, changed everything. Rocks don't protect interiors. Machines do, because inside is where the important parts live. The silence from official channels deepened. NASA didn't deny the surface behavior. They simply stopped emphasizing it. The data stayed public. But no one talked about it, because talking gives shape to fear. And shape gives fear power. But you don't need words to feel it. Anyone who looked long enough could see the pattern. Light, heat, pulse, surface, all moving together, all adjusting together, all behaving like parts of a whole. And that's when a final, haunting question emerged. If this surface is learning where to look, what is it looking for? Not the sun. It already understands the sun, not Earth. We're insignificant at this scale. So what matters enough for a machine crossing interstellar space to adjust its surface, to refine its exposure, to protect itself so carefully? That question had no answer, only implications. Because once you accept that this object adapts, you have to accept the next step. Adaptation exists to serve a purpose. And purposes don't appear by accident. As 3I/Atlas faded slowly into the outer darkness, the reflectivity stabilized. No more dramatic shifts. No more learning. Like a student who had finished the lesson, and the most unsettling thought of all settled in quietly. Maybe it wasn't learning how to survive our solar system. Maybe it was learning what mattered inside it. And in the next chapter, that thought would grow even darker. Because if this object is adapting like a machine, then someone would eventually ask the question no one could avoid forever. What happens when we stop calling it an object and start calling it what it behaves like? They didn't announce it. There was no meeting invite, no official request, no bold subject line. Just a small group of people staying late, closing doors, lowering their voices. Because by this point, everyone felt it. The word no one wanted to say was already in the room. Machine, not alien, not life. Machine, that matters. Because life is messy, emotional, unpredictable. Machines are quiet, patient, precise. And 3I/Atlas had been precise from the beginning. So one night, almost casually, someone did something simple and irreversible. They changed one assumption. Instead of modeling 3I/Atlas as a natural object, a rock, a comet, a broken piece of debris, they modeled it as artificial, not as a spaceship, not as a probe, just as a constructed object, something built, then released. At first, it felt wrong, like cheating. Science isn't supposed to start with conclusions, but curiosity doesn't always wait for permission. They fed the same data back into the simulations. The light curve, the pulse, the thermal regulation, the reflective shifts. Only this time, they allowed one new possibility, that the object was designed. The result was immediate and unsettling. The models stopped breaking, where before they needed dozens of excuses. Dust here, rotation there, unknown chemistry everywhere. Now the behavior aligned, cleanly, elegantly. The pauses in brightness made sense. The thermal stability made sense. The surface adjustments made sense. Not perfectly, but better, much better. That's when the mood changed. Because science doesn't reward belief, it rewards fit. And this fit was uncomfortable. The object didn't need to be intelligent. It didn't need to think. It only needed to function. A system designed to survive long travel, to manage energy, to protect itself. Nothing exotic, just engineering. And that's what made it terrifying. Because engineering is familiar. Humans build things like this. We send machines across space all the time. We shield them. We regulate their heat. We adjust their orientation. We design them to last. So the question shifted. Not could this be artificial? But why does artificial explain it so well? The group ran more tests. They treated the pulse as a timing system. Suddenly, it fit. They treated the reflectivity shifts as adaptive surface control. It fit. They treated the thermal curve as internal heat management. It fit. Not proof, but coherence. And coherence is dangerous. Because once a theory explains multiple anomalies at once, it stops being a coincidence. It becomes a contender. No one wanted to be the first to say it out loud. So they asked a safer question instead. What if this is just debris? A broken machine? A fragment? Something abandoned long ago? That idea brought brief relief, because broken things don't have purpose. But the data didn't agree. Broken systems fail. They drift. They decay. They lose coordination. 3I/Atlas was coordinated. Every part talked to every other part. Light, heat, surface, all moving together. That's not debris. That's integrity. Someone finally said it. Not loudly, almost apologetically. If this is artificial, it's still working. The room went quiet. because that single sentence rewrote everything. If it's still working, then it wasn't meant to burn up. It wasn't meant to crash. It wasn't meant to stop here. Which means this wasn't an accident. And accidents are comforting. Intent is not. That's when the deeper question emerged. Not what is it, but how old is it? Because interstellar space is unforgiving. Radiation erodes. Collisions happen. Time destroys. Anything crossing between stars for millions of years needs planning, redundancy, protection, efficiency. All things machines excel at. And 3IATLAS showed signs of all three. So the group looked at its path again, not just where it was going, but where it came from. The origin couldn't be traced cleanly. Too much time, too much drift. But one thing was clear. This object did not belong to our system. It wasn't captured. It wasn't flung out and returned. It arrived, cleanly, purposefully, at an angle that minimized disruption, like it wanted to pass through, not collide. That raised the sharpest question yet. Does origin matter more than distance? Because we like to believe that danger comes from closeness, that threats arrive suddenly, that discovery happens at the moment of encounter. But what if the most important part of this story happened long before we ever existed? What if this machine was built around a star that died, by a civilization that faded, sent out not to visit, but to endure? That idea scared people more than invasion ever could, because invasion implies urgency. This felt patient, ancient, like something designed to outlast its creators. The simulations kept running, and with every artificial assumption, the system grew quieter, less chaotic, more understandable, as if the object had been waiting for someone to finally ask the right question. Still, no one pressed publish, because once you suggest artificial origin, you cross a line science can't uncross. Funding changes. Politics follow. Fear leaks. So the work stayed unofficial. Unspoken. Just a few minds circling the same realization from different angles. This wasn't about aliens. This wasn't about contact. This was about technology without contacts. A machine without a manual, a tool whose purpose was unknown. And that is the most dangerous kind of discovery. Because tools are meant to do something, even if they're quiet, even if they wait. Someone asked one final question. If this is a machine, what stage is it in? Launch? Transit? Shut down? The data hinted at something subtle. The adjustments were slowing. The pulses were stabilizing. The surface changes were fading. Like a system reaching equilibrium. Not failing. Completing. That thought lingered. Because machines don't linger once they're done. They move on, or they sleep, or they wait for the next trigger. And triggers don't have to come from us. The sun faded behind 3I/Atlas. The inner system fell away, and still it held together. No breakdown, no loss of control, just silent persistence. At some point, the group stopped running simulations, not because they were done, but because they all reached the same conclusion independently. Treating it as natural required excuses. Treating it as artificial required only acceptance. And acceptance carries weight. Because once you accept that this object might be a machine, you have to accept the next truth. Machines reflect their makers, their values, their priorities, their understanding of the universe. So what does this machine tell us? It values endurance, efficiency, silence. It doesn't announce itself. It doesn't communicate openly. It doesn't care if it's noticed. And that's when the most unsettling realization of all arrived. If this machine exists, then someone, somewhere once believed the universe was worth crossing. Not to conquer, not to speak, but to leave something behind. And if that's true, then 3I/Atlas isn't the question. It's the evidence. Evidence that we are not the first to send machines into the dark, and not the first to hope they would survive long enough to be found. As the object drifted farther away, the simulations went quiet, not because the mystery was solved, but because it had changed shape. This was no longer a question of astronomy. It was a question of perspective, of humility, of whether distance really protects us or merely delays understanding. And in the next chapter, that understanding would escape the lab, because once humans sense something bigger than themselves, silence never lasts. It didn't start with an announcement. It started with a screenshot, a cropped graph, a blurry chart, a message sent too late at night to the wrong person. That's how silence breaks. Someone shared a fragment of data, nothing dramatic on its own, but enough to spark curiosity. Then someone else added context. Then speculation. Within hours, the quiet world of peer review collided with the loudest force humanity has ever built, the internet. At first it was subtle, a post asking, "Why is this light curve wrong?" A thread pointing out temperature data that didn't match solar logic. A comment that ended with, "This doesn't look natural." Then it spread. Screenshots jumped platforms. Graphs lost captions. Contexts dissolved. And suddenly, 3I/Atlas wasn't a file name anymore. It was a question. Social media did what it always does. It split. One side leaned forward in awe. This changes everything. We're not alone. They've been watching us. The other side leaned back in denial. Bad data. Fake science. Another hoax. Because disbelief is easier than uncertainty. And uncertainty was everywhere. People slowed videos down, drew circles on images, compared frames. Every flicker became proof. Every pause became intention. But just as fast, the noise turned hostile. Experts were accused of hiding truth. Agencies were accused of lying. Anyone calm was accused of knowing more than they said. Human static filled the air. Fear mixed with excitement. Wonder mixed with rage. It always does. Because when people sense something bigger than themselves, they don't respond with patience. They respond with projection. Some saw hope. Some saw threat. Some saw God. Some saw doom. Everyone saw what they were already afraid of. News outlets picked it up. Carefully at first. Unusual interstellar object sparks debate. Safe words. Soft language. But headlines don't stay soft for long. Soon it was NASA hiding alien evidence. Mysterious object defies physics. Is something watching us? The truth didn't matter anymore. Only perception. And perception fractured. Meanwhile, inside observatories, the screens stayed quiet. No sudden spikes. No changes. No reaction. 3I/Atlas didn't flare, didn't pulse faster, didn't adjust its surface. It didn't respond to attention. That detail bothered scientists more than the chaos outside, because human systems react to attention. Markets move, politics bend, people change behavior when watched. Machines only react to inputs, and 3I/Atlas showed no sign that we were one. The pulse continued. Same timing, same strength. The thermal balance held steady. The reflectivity stayed calm, as if none of this mattered. As if the noise didn't exist. That contrast was unsettling, because if this object were alive, it might hide. If it were intelligent, it might adapt. But it didn't. It stayed exactly as it was. As if its task had nothing to do with us. That realization cut through the panic for a few people. What if this isn't about contact? What if it never was? The loudest voices online insisted meaning had to be assigned. It had to be a message, a probe, a warning. Because humans struggle with randomness, we need intention. But intention doesn't require an audience. Machines don't care who's watching. They care about function. As debates raged, a strange thing happened. Interest peaked, then fractured. Some people lost focus and moved on. The news cycle shifted. A new outrage replaced the old one. Only a core group remained, watching quietly, checking updates, refreshing graphs, and the object continued its path, unchanged. That's when the question grew sharper. Why does it ignore us? Not in arrogance, not in malice. In indifference. Because indifference implies hierarchy. You don't ignore what you fear, you ignore what doesn't matter. That thought unsettled everyone who considered it seriously. Because humanity likes to believe it is central. Observations shape reality. Awareness creates meaning. But 3I/Atlas didn't acknowledge awareness. It didn't care that millions were staring at it. It didn't alter course. It didn't shield itself further. It didn't communicate. It didn't even hide. It simply continued. As if the moment of interest was irrelevant. As if this phase had already passed. As if whatever it was doing was already done. That idea felt cold. Because it suggested we weren't early. We weren't witnesses to a beginning. We were late. Late to notice. Late to listen. Late to understand. The loudest voices online argued over definitions. Alien or not. Natural or artificial. Threat or curiosity. But those questions missed something important. No one asked whether the object needed us at all, because need implies dependence. And nothing about 3I/Atlas suggested dependence. It crossed interstellar space without support. Managed heat without fuel. Adjusted surfaces without command. It existed without us, and would continue without us. That's a hard truth to sit with. NASA issued statements, measured, careful. There is no evidence of artificial origin. Data remains under review. No cause for concern. Every word was technically true and emotionally useless, because emotion doesn't respond to reassurance. It responds to mystery. And mystery doesn't disappear when denied. Behind the scenes, the reaction mattered less than expected. The object didn't change when we argued. It didn't change when we panicked. It didn't change when we stopped paying attention. That consistency spoke louder than any headline. This was not a performance. It wasn't feeding on fear. It wasn't reacting to belief. It was following its own internal logic. And internal logic means internal goals. That's when a quieter thought surfaced. What if this object passed through countless civilizations, each one reacting, arguing, projecting. And none of that ever mattered? What if the universe is full of machines that don't care who notices them? That possibility reframed everything, because it meant we weren't special. Not as observers, not as thinkers. Just another species watching the sky, trying to feel important. The human noise faded, not because answers arrived, but because attention moved on. Only a few kept watching. Only a few kept listening, and those few noticed something subtle. The object wasn't responding to us, but it was responding to time. The pulse continued, the systems stabilized, the adjustments slowed, like a process approaching completion. And that raised a final, haunting question. If 3I/Atlas ignores our reaction entirely, then what moment is it actually waiting for? Because machines don't wait for applause. They wait for conditions. And conditions don't always involve us. As the noise of humanity dissolved into the background hum it has always been, 3I/Atlas moved on. Calm, silent, unchanged. And in that calm, a deeper fear took root. Not that something was watching us, but that something passed by, noticed nothing worth stopping for, and kept going. In the next chapter, the data would reveal something even more unsettling. Because while humans argued, the object was doing something else entirely. It was leaving behind a pattern, one that could not be ignored. At first, it looked like coincidence. That's how patterns always begin. Small overlaps, shared timing, moments that feel connected, but could still be random. So scientists did what humans have done forever when faced with uncertainty. They waited. They watched longer, because time has a way of stripping excuses away. Weeks turned into months. 3I/Atlas moved farther from the sun, slipping back into the dark where most objects fade into irrelevance. But the data didn't fade. It grew clearer. When researchers laid everything out, the light curve anomalies, the pulse timings, the thermal shifts, the reflectivity changes, something unexpected happened. They aligned, not loosely, not vaguely, precisely, like pieces of a structure finally snapping into place. Every anomaly pointed back to the same repeating cycle. Not orbital, not rotational, something deeper, a core rhythm. The pulse was the key. It always had been. When they synchronized all datasets to the pulse timing, the chaos disappeared. Light fluctuations matched specific pulse phases. Heat adjustments followed predictable intervals. Surface reflectivity changed at the same points in the cycle. What once looked like noise now looked like choreography. That realization changed everything, because chance scatters, patterns organize, and this was organized. The cycle repeated again, and again, and again. No drift, no decay, just repetition. That's not how natural systems age. Stars wobble, comets break apart, chaos creeps in, but this structure held, as if time itself couldn't erode it. Someone plotted the full cycle length, then cross-checked it, then recalculated it using independent clocks. The number stayed the same. Every time, it didn't care who measured it. It didn't care when. The pattern was absolute. That's when the word architecture quietly entered the conversation. Because architecture implies planning, not reaction, not accident. Planning. This wasn't a pattern caused by environment. The sun didn't create it. Distance didn't shape it. Gravity didn't enforce it. The pattern existed independently, and everything else adjusted around it, like a spine holding a body together, and that raised an uncomfortable truth. This object wasn't responding to the solar system. The solar system was briefly interacting with its process, which means the most important part of this object wasn't what we could see. It was what we were interrupting. The group studying the long-term data noticed something subtle. The pattern didn't change when conditions changed, not when solar radiation peaked, not when human observation intensified, not when instruments changed. The structure stayed intact. Only the surface behavior adapted. That's another trait of machines. Core systems remain stable. External layers adapt. The longer they watched, the clearer it became. This wasn't randomness settling into order. It was order revealing itself over time. That realization felt heavy, because it suggested intention without communication. The pattern didn't announce itself. It didn't broadcast. It didn't escalate to be seen. It simply existed, patiently, waiting for anyone who would look long enough. And that raised the question no one could avoid anymore. Was this designed to be noticed? Or was it never meant for us at all? Some argued it had to be intentional. Why else maintain such precision? Why build a structure that survives interstellar travel only to hide it? But others disagreed. Machines don't need audiences. They need reliability. What if this pattern wasn't a message, but a log? A record? A system keeping track of its own journey? Timestamps, status checks, internal cycles. The pulse could be nothing more than a clock, a machine counting its own existence, not caring who overhears. That idea felt colder than contact, because it meant we weren't part of the equation. We were bystanders, eavesdropping on a process never meant to include us. Someone pointed out something even more unsettling. The pattern didn't encode information. No primes, no sequences, no mathematical greetings, nothing designed to say hello, just repetition, which suggests function, not communication. It wasn't speaking. It was operating. That distinction matters, because speaking implies awareness of the listener. Operating does not. As 3IATLAS drifted farther away, the signal-to-noise ratio worsened. Data became thinner, harder to read, but the pattern remained visible, even through distortion, like a song you recognize even when played softly. That endurance changed how people felt about it. This wasn't fragile. This wasn't temporary. This structure had crossed unimaginable distances intact. Which means it was built to last, longer than civilizations, longer than stars. And that idea humbles you, because humanity has existed for a blink. Our machines fail within decades. Our records decay. Yet this pattern endured space, radiation, time, and still repeated faithfully. That doesn't feel accidental, but it also doesn't feel welcoming. It feels indifferent. Somewhere along the line, the conversation shifted again. Not what is it, but what does it represent? A probe, a beacon, a relic, or something stranger? A test of persistence, a proof that intelligence once existed and believed the universe was worth leaving a trace in. Not a message, not a warning, just evidence. The simplest and most haunting kind, because evidence doesn't explain itself. It only proves something happened. The object continued its outward journey. The sun shrank behind it. The inner planets fell away. Soon, observation windows would close. Soon the data would thin beyond usefulness. But the pattern didn't rush. It kept repeating, as if it didn't care whether it was ever fully understood. That's when a quiet realization settled in. Maybe this pattern wasn't designed to be noticed quickly. Maybe it was designed to be noticed eventually, by any civilization patient enough, curious enough, humble enough, to stop asking what it wants and start asking what it is. And that distinction matters. Because if this object carries a repeating structure across the galaxy, then it is not unique. It is a type, a class, something that can be built again. And that leads to a chilling possibility. What if the universe is full of these? Not watching, not waiting, just passing through, running their cycles, leaving patterns behind like footprints in time. We don't notice them because we don't look long enough. And when we do, we mistake patience for silence. As the last clear data came in, the pattern remained intact. No sign of breakdown, no deviation, just the same quiet rhythm beating against the void. And that final image stayed with everyone who saw it. A machine, or something like one, crossing the dark, keeping time, not for us, but for itself. Which leaves one question hanging in the cold. If this pattern was never meant to be noticed, if it's merely a record of passage, then how many others have already passed by, leaving patterns we never recognized because we weren't listening long enough? And, more importantly, what happens when we finally encounter one whose pattern does include us? Because patterns don't lie, they wait. And in the next chapter, that waiting would come to an end, not with a message, but with something far more unsettling. Silence. It didn't stop suddenly. That's the part people misunderstand. Silence didn't arrive like a switch flipping off. No sharp ending, no dramatic drop. It came slowly, almost politely, as 3IATLAS moved farther from the sun, past perihelion and back into deeper space. The pulse began to weaken, not vanish. Weaken. The beat that had stayed so steady, so patient, so precise, started to thin. At first, no one trusted it. Signals fade all the time. Distance stretches them. Noise eats them. Space swallows everything eventually. So the first instinct was technical, better filters, longer integration times, more sensitive instruments. They listened harder. And for a while, it worked. The pulse was still there, faint, soft, but real. Like a heartbeat heard through a wall. But with each passing week, it grew quieter. Not erratic, not broken, just fading. That detail mattered. Because failure looks messy, systems collapse unevenly. Timing slips, patterns distort. This wasn't collapsing. It was concluding. The pulse spacing stayed consistent. The structure held. Only the strength declined. Like a voice lowering itself, not being cut off. The same thing happened with the light curve. The strange adjustments softened. The deliberate pauses blurred into the background. Still unusual, but no longer sharp enough to stand out. Thermal behavior followed. The careful regulation relaxed, not overheated, not frozen, just drifting toward equilibrium. Like a machine no longer protecting critical systems, like a process no longer under stress. That's when the fear changed shape. Because if this were a malfunction, there would be signs. If it were damage, there would be asymmetry. But everything faded together, in order, as if guided. Someone finally asked the question no one had wanted to ask before. What if this isn't breaking down? What if it's shutting down correctly? The room went quiet. Because shutdown implies completion, not failure. Completion means purpose, and purpose means this object came here to do something, something that might already be finished. The idea spread slowly, carefully, because it's one thing to say an object behaves like a machine. It's another to suggest that machine has finished its task. The pulse was the hardest to let go. For months, it had been the spine of everything, the clock, the anchor. Now it was slipping below detectability, still there, but only barely. Each detection felt like catching the last echo of a sound that had already passed, and that raised a haunting possibility. What if the pulse was never meant to last forever? What if it was only meant to operate under certain conditions? Near a star, within a system, during passage. Once those conditions ended, so did the need for activity. That would explain everything. The careful approach, the controlled exposure, the adaptive surface. All of it focused on surviving the inner system. Now that survival was no longer required, so the systems powered down. Not dramatically, gracefully, like a probe entering hibernation. Or worse, like an experiment ending. The word experiment made people uncomfortable because experiments have variables and environments and observers, even if they're not human. Some wondered if the sun itself was the target. Maybe the object was measuring stellar behavior, radiation patterns, magnetic fields, something we barely understand. If so, then Earth was never relevant. Just background noise. That would explain the indifference. That would explain the silence. Others suggested something even colder. What if this object wasn't studying anything at all? What if it was simply testing endurance, a proof of concept, a demonstration that a structure could cross interstellar space, pass close to a star, and emerge intact? No data transmission required. No message needed. Just survival. If that's true, then the silence isn't loss, it's success. That thought settled heavily, because success means repetition, and repetition means this isn't unique. It means this has been done before and could be done again. As the pulse weakened further, detection became statistical. You couldn't see it anymore. You had to infer it, like tracing a vanished animal by footprints fading in the sand. At some point, the question changed again. Not, is it still there, but when do we stop saying it is? Because science hates uncertainty. It demands thresholds. And eventually, the pulse crossed below them. Officially, the signal was gone. Unofficially, some swore they could still feel it. A phantom rhythm, a memory of repetition. But memory isn't data, so the charts flattened, the graphs normalized. The anomaly disappeared into the noise it once stood apart from. That's when the story should have ended. That's when everyone expected closure. Instead, unease remained, because silence answered nothing. It only removed questions. And removing questions doesn't feel like resolution. It feels like loss. The object itself continued outward, still visible, still tracked, but now unremarkable. No pulses. No sharp behavior. Just another cold traveler leaving the inner system behind. And that normality felt wrong. Because normality felt wrong. Because Normal doesn't erase history. The data hadn't been disproven. It had simply stopped. And stopping is meaningful, especially when it happens cleanly. Someone noticed something subtle in the final datasets. The last strong pulse occurred shortly after perihelion. Not before. Not long after. Right at the midpoint of the journey. As if that moment mattered. As if the passage through the inner system had a defined beginning and end. That detail refused to fade, because if the silence marks completion, then the real action already happened, and we might never know what it was. That idea is harder to live with than any alien story, because aliens imply future contact. This implies missed opportunity, or worse, irrelevance. What if humanity was never meant to notice? What if noticing changes nothing? Machines don't wait for applause. They don't care about interpretation. They execute and move on. And that's exactly what 3IATLAS did. No farewell, no final spike, just a slow retreat into quiet. As the sun's influence weakened, so did our access. Observation windows narrowed. Signal to noise worsened. Soon, tracking would rely on estimates, not measurements. And with that came a sobering truth. We were losing it, not physically. Conceptually, the object was slipping back into the category it had briefly escaped. Unknown, unexplained, unreachable, but now with memory. And memory changes everything, because once you've seen a pattern, you can't unsee it. Once you've heard a pulse, silence feels loud, and that silence carried one final question. If this was the end of an experiment, what was the experiment for? Testing materials, testing endurance, testing stars? Or testing something else entirely, something we don't yet know how to measure? Because experiments don't always test the obvious variable. Sometimes they test observers. Patience, curiosity, interpretation, the ability to listen without being addressed. The object faded. The data thinned. The silence settled. And with it came a realization as unsettling as any signal. The universe may be full of machines that pass through quietly, doing their work, then leaving without ever asking if we noticed. And if that's true, then the real question isn't why the signal stopped. It's why we assume it was ever meant to continue. Because silence doesn't always mean absence. Sometimes it means the task is done. And in the next chapter, that silence would force a decision. Not about the object, but about us. What we choose to remember and what we choose to archive and forget. It ended the way most uncomfortable stories do. Quietly. No press conference. No final update. No dramatic conclusion. Just paperwork. Reports were finalized. Language was softened. Margins were trimmed until nothing sharp remained. 3I/Atlas became a file, a case number, a closed folder. In the official summaries, the story was simple. Interstellar object observed. Unusual but explainable behavior. No evidence of artificial origin. Each sentence was technically true and completely hollow. Because truth doesn't always disappear. Sometimes it's just buried, archived under calm words and neutral tones. The anomalies didn't vanish. They were reorganized. Light curve irregularities became instrumental variants. Thermal regulation became unusual thermal inertia. The pulse became statistical noise near detection limits. Nothing was erased, everything was rephrased. That's how institutions survive uncertainty. You don't deny it, you flatten it. Footnotes replaced questions. Graphs were compressed until patterns were harder to see. Time windows were narrowed. Long-term correlations were labeled inconclusive. And just like that, the mystery lost its shape. To the public, the story ended. Another strange object. Another overblown theory. Another internet phase that burned out. People moved on. They always do, because attention is fragile. And mystery without payoff fades fast. But for those who had followed the data from the beginning, the ending felt wrong. Not false, incomplete, like a book missing its final chapter. Inside agencies, the language mattered. Words like machine were never written. Artificial appeared only to be dismissed. Intent was avoided entirely. Instead, there was a phrase that kept appearing again and again. Insufficient evidence to conclude. That sentence does a lot of work. It doesn't say no. It doesn't say yes. It says, not now. And not now is a powerful decision, because it places authority over timing. It answers a different question altogether. Not what is true, but what are we ready to accept? That's the real function of archives. They don't store answers, they store delay. Some data was classified, not because it was dangerous, but because it was unresolved. Unresolved data creates problems. It invites interpretation. It invites speculation. It escapes control. So it was sealed, not forever, just for now. The justification was reasonable. More analysis needed, better instruments required. Future missions may clarify. All of it made sense. And none of it brought closure. Because closure requires explanation. And explanation was exactly what no one had. In private, some scientists were relieved. The pressure eased, the noise faded. They could return to safer questions. Exoplanets, atmospheres, things that behave. But others felt something else. Loss, not of an object, but of a moment. Because moments like this don't happen often. Moments when the universe offers a glimpse of something that doesn't fit. Something that asks more questions than it answers. And those moments shape how we see everything after. Archiving the truth doesn't erase it. It just pushes it out of sight, into quiet corners where only a few remember how strange it really was. The final reports contained no lies, but they lacked curiosity. And curiosity is the engine of discovery. Without it, data is just numbers. One line in a report stood out to those who read carefully. Further anomalies not deemed significant within current models. Within current models, that phrase matters because models are choices. They define what counts as possible. Anything outside them isn't impossible. It's inconvenient. So the truth was archived, not answered. And that raised an uncomfortable question. Who decides when the world is ready? Scientists? Institutions? Governments? Or reality itself? Because the universe doesn't wait for readiness. It doesn't care about public reaction. It doesn't soften discoveries for comfort. That's a human habit, and it's not always a bad one. But sometimes it delays understanding. As the months passed, interest waned. 3I/Atlas drifted farther away. Eventually, it would be too faint to track at all. It would join the countless other objects moving silently between stars. And the official story would stand. A strange object, nothing more. Yet among those who knew the full arc, the archived truth lingered. They remembered the pulse, the coordination, the pattern that refused to decay. They remembered how artificial models fit better than natural ones. They remembered the silence arriving cleanly, not chaotically. Those memories don't vanish just because a report is filed. They wait, like the object itself. One researcher described it quietly, years later. It felt like we shelved a question we weren't ready to ask. That's the real cost of archiving truth, not deception. Delay. Because delay assumes the question will still matter later, that someone else will ask it again. That future instruments will see what we couldn't. That future minds will be braver, or more patient, or less afraid of ambiguity. Maybe they will. But maybe the moment has passed. Maybe the object did what it came to do and moved on. And all we're left with is a record of almost understanding. The archive doesn't answer questions. It preserves them, locked behind access controls and careful language. Waiting for a time when curiosity outweighs caution, or when evidence becomes impossible to ignore. Until then, the truth sits quietly, not denied, not confirmed, just filed. And that's how the story officially ends, with calm words, neutral conclusions, and a sense that something important slipped through our fingers. But unofficially, the story doesn't end at all, because archiving isn't the same as forgetting. And forgetting isn't the same as resolution. The data exists. The patterns exist. The silence exists. And silence has a way of echoing, especially when it follows something that felt deliberate. In the end, the question isn't whether the truth was hidden. It's whether the truth was ever meant to be revealed all at once. Maybe understanding doesn't arrive as an answer. Maybe it arrives as a slow shift in perception, a realization that not everything in the universe is meant to engage us. Some things simply pass through, leave traces, and move on. And it's up to us to decide what to do with that knowledge, to bury it, or to sit with it. Because the archive isn't the end of the story. It's the pause before the last question. A question that no report can answer. One that belongs not to scientists, but to all of us. And in the final chapter, that question will no longer be about 3I/Atlas at all. It will be about what its silence forces us to confront. About ourselves. About meaning. About whether knowing is more important than being ready. Because once the truth is archived, the responsibility doesn't disappear. It just changes hands. In the end, it leaves the same way it arrived. Quietly, no signal, no flare, no final adjustment to mark its passing. Just a dim point of light shrinking against the dark. 3I/Atlas drifts beyond the reach of our strongest instruments, slipping back into the space between stars, the place where names lose meaning and charts turn blank. The inner system exhales. The sun keeps burning, planets keep circling, life goes on. And on the surface, everything looks normal again. The charts are clean now, light curves smooth, thermal lines flat, no pulses, no anomalies. If you only look at the final graphs, nothing feels wrong. That's the danger of endings. They simplify what came before. But the people who watched it closely, who followed every shift, every pause, every pattern, they don't feel relief. They feel unease. Because normalization isn't explanation. It's just what happens after something stops asking to be understood. 3I/Atlas is gone. Not destroyed, not captured, just gone from relevance. And that absence leaves a question hanging in the quiet. If this object was artificial, what does that make us? Not in comparison, in position. Because for all our technology, all our telescopes, all our confidence, we noticed it late. We argued about it loudly, and we understood it barely at all. That realization humbles you. Because humanity likes to believe it stands at the edge of discovery. That when something enters our space, it enters our story. But 3I/Atlas never felt like it belonged to our chapter. It felt like a sentence from a much longer book. One written long before us and continuing long after. If this was a machine, then it wasn't curious. It didn't explore. It didn't greet. It didn't test us. It passed through, which suggests a universe that doesn't revolve around observers, a universe where intelligence doesn't always seek recognition, where technology doesn't always announce itself. That idea feels cold until you sit with it, because it also means the universe is older, deeper, and more layered than our fears. It means not every unknown is a threat. Some are just indifferent. And indifference can be harder to accept than hostility, because hostility acknowledges you. Indifference does not. As 3I/Atlas fades into the dark, one truth becomes impossible to ignore. If it was artificial, then intelligence can exist without communication, without conquest, without legacy. Just function. Just persistence. That changes how we think about life in the universe. Not as neighbors waiting to speak, but as builders who leave traces and move on. And that forces a deeper question. Were we ever meant to understand this? Or is understanding something we project onto a universe that doesn't owe us clarity? Because maybe knowledge doesn't always arrive as answers. Maybe it arrives as limits, a boundary where curiosity meets humility. 3I/8 didn't give us a message. It gave us a mirror. It showed us how quickly we jump to meaning, how loudly we fill silence, how uncomfortable we are with not being central. We asked if it was watching us. But maybe the real question was simpler. Why did we assume it should? The object didn't slow for Earth, didn't change course, didn't react to attention or belief. It treated our solar system the same way it likely treated countless others, as a place to pass through. And that suggests something profound. The universe may be full of stories that don't include us. Full of machines, structures, relics, and systems, each carrying their own logic. Not hostile, not friendly. Just existing. We like to think discovery changes everything, but sometimes discovery only changes us, our assumptions, our confidence, our sense of importance. 3I/Atlas didn't rewrite physics. It didn't prove aliens. It didn't save or doom us. What it did was quieter and more lasting. It forced us to confront a truth we often avoid, that the unknown doesn't always resolve itself, that mystery doesn't always have an ending, that some questions are not puzzles to be solved, but realities to be lived with. As the last confirmed observations were logged, One scientist wrote a single line in a private note. Whatever it was, it didn't need us. That sentence lingers. Because need implies hierarchy, and the absence of need implies something else entirely. A universe that doesn't wait, doesn't pause, doesn't explain itself on our schedule. And that's not a reason for despair. It's a reason for perspective. If this object was artificial, then intelligence is older than we imagined, more patient, less dramatic, and perhaps more restrained. That should change how we look at the sky, not with fear, not with fantasy, but with respect. Because the universe might be filled with quiet achievements we don't yet know how to recognize. 3I/Atlas leaves behind no ruins, no signal, no confirmation, just data and doubt. And doubt is not failure. Doubt is the beginning of wisdom. Because certainty closes doors, doubt keeps them open. The unanswered origin remains exactly that. Unanswered, not because the truth is hidden, but because the truth may not be something that fits into words, or headlines, or conclusions. Maybe it fits only into patience, into the slow work of watching without demanding meaning. As the object fades completely from view, one final thought settles in. Perhaps the universe is not a conversation. Perhaps it is a library, filled with traces of those who came before, waiting not for anyone in particular, but for anyone capable of noticing. And maybe one day, far from now, another civilization will notice us. Not because we called out, not because we mattered to them, but because something we built quietly endured. Until then, the sky remains vast, indifferent, honest, and somewhere out there, 3I/Atlas continues its journey. Still intact, still silent, carrying its origin with it, unexplained, leaving us with the final, uncomfortable truth. The universe does not exist to be understood. It exists to be encountered. And sometimes, encountering the unknown doesn't give us answers. It gives us humility. And that may be the most important discovery of all.